6 is about the chain rule. And I wouldn't worry at all about writing this down. I would worry about the idea. The idea is that if you have like a trig function and you're taking the derivative of it, derivative of sine of x squared plus e to the x. This is the inside. It's also called the argument. And so if I say argument, that's what I'm talking about. So when you do that, you take the derivative of this function. So the derivative of sine is cosine. Then you write the argument as is. You don't change it. But you multiply by the derivative of the argument or the derivative of the inside. That's what we call the chain. So it's this, take the derivative of this, write down this again, and then take the derivative of the inside. Okay?
That's how you leave it.
Sometimes it depends. Sometimes you have to go ahead and multiply it out, but you can't multiply this times this. There'll be some times in chain rules, not necessarily in trig, where you do, but this is the cosine of this times this, so you wouldn't do anything else. We saw a little bit of the chain rule, bless you, when you had the derivative of e to the u, the derivative of e to something other than plain old x, which meant you did e to the u, but you had to multiply by the derivative of u. Okay, you saw that in a couple of problems that we had. Okay, so that's that one. And then the power chain rule. I don't know what that's doing. Really, it would be like, let me think of a better example. So if you had the derivative of x squared plus 3x to the fourth, so this is y, and you wanted to take the derivative of it, what would we do? We'd bring the 4 to the front, so we have 4 times that to the third times the derivative of this inside, which would be what?
2x.
Okay. Now, you can't multiply 2x by 3, 2x plus 3 times this, because this is to the third power. So you can multiply it by the 4, so you could have 8x plus 12 times this to the third. So you can clean things up some, but that's the chain rule. Same idea of just the power thing, but you do have to multiply by the derivative of the inside. Does that make sense? Ring a bell for those of us that have seen it before. And the derivative of the absolute value function, I put that in there, but I didn't give you any on the homework, and so I just have it here for reference. But the derivative of absolute value is x over the absolute value of x. Okay, that may be on that sheet. I don't know if it's on your.
It is.
It is on there.
It's number 8.
Number 8. Okay, so you have that one. Okay. So really that's the rules that I wanted to give you, that we wanted to highlight, and then we're going to actually work problems. Okay? I'm going to work several, and then hopefully you will work some, okay, to get used to it. All right, is everybody through with anything they're writing here? Okay. Oops. Whoops. Okay. All right, these are kind of written a little bit different, so we have to kind of go over that. This gives you y equals, write it here so you can see it a little better, 8u plus 1, and then it says u is 1/4 x to the 6th. So what is that saying with that chain thing? It's saying, okay, let's go ahead and put u in here. This is just kind of getting started. So really we have y equals 8 times 1/4 x to the 6th plus 1. So what does that give me? 2x to the 6th plus 1. And then dy dx would be what? 12x to the 5th. So this is just, because the chain rule really comes from composites, from things being put into other functions. So we're kind of just starting out putting another function in and then taking the derivative of it. On this one, we could actually clean it up first before we did that. Okay? All right, and this one, a little bit small. Let's see if I can make it bigger for you. See if you can think about how this would be written as a problem. Given y equals sine u and u equals 3x plus 4, what are we going to write as our equation?
Sine open parentheses 3x plus 4 plus.
Okay, and so how do we take the derivative of that? dy dx.
Outside.
Cosine.
So cosine,
3x.
okay, times 3. Okay. And so then you would write it, typically, 3 cosine of 3x plus 4. Yes?
What's that where it says like 4 dx there?
Up here?
Yeah.
Mm-hmm. And that's actually equals.
So how's that the same thing as what we're doing?
It's the same thing we're doing. We're taking f prime of g of x, and then we're multiplying it times g prime of x, which is what we're doing. We're taking the derivative of this guy, okay, and then we're multiplying it by the derivative of this guy. And so what I didn't want you to get caught up with was what is that? You know, that's a formal way to write something, but if you can understand the concept, what I'm doing is taking the derivative of the main thing. So derivative of this guy, that's your f prime of g of x, because we put that in there, times the derivative of this thing. That's g prime of x. Is that a little better? Okay.
It says using the g of x up there.
Yeah. Yeah. Okay. Let's try this one. Do I need to make it a little bigger? Okay. We've got that same thing going on. All right, except they've already written it this way and they want us to come backwards and say what's f of u and what's g of x. Can you tell what g of x would be?
Cosine x.
Do what? Oh, we did? We just went over 3? Where did it go? What happened?
Homework's better be like that.
We did. Did I cover it up when I made it larger? No?
Let's check it out.
Okay, hold on. Yeah, I can, but it's not a democracy. Okay, here's what it was, evidently, but I don't know why it's gone, but let's look at it. Write the function in the right form. If we've got y equals 7x plus 19 to the 4th, okay, we want to put it in that what's u and what's g of x. Do you get what I'm saying? So I could write this as y equals u to the 4th, where u is 7x plus 19. Does that make sense? We just kind of went backwards on this one. They're giving you this, where they had been giving us these two pieces. And so we chose C, and then they say, okay, well now take the derivative of it. And so the derivative of that thing right here is 4 times that to the 3rd, and then times the derivative of this, which is 7. Does that make sense? And when we go back and we start on question 4, it's the same idea. They're giving us the equation and we're writing it backwards into the two pieces. Are we good? Okay. Are you still writing, Mitchell? Okay. Let me know when you're done. You good? Okay. Okay. So now we'll go to 4. Okay. So now 4 says, what are the two pieces? What would we write for what's f of u? Cosecant u? Would be one way to do it. And what is g of x? Cosine x. And so now let's find the derivative of that. So what is the derivative? And if you need your sheet in front of you, what is the derivative of cosecant?
Cosecant, cosecant.
Okay, so negative cosecant cotan of cosine x times, what's the derivative of cosine x?
Sine.
Okay, negative sine x. Okay, so can you see that that negative and that negative are going to cancel each other out?
But would you still have x right behind cosecant? Or would that doesn't make sense?
This is cosecant cotan of cosine x.
Well, but would you put x right after cosecant? Because
Well, this we're going to distribute this in the next step. Is that what you're worried about?
yeah, well, because there's
Like there has to be an argument.
yeah.
And so the argument is right here. So this is actually cosecant cosine x cotan cosine x sine x. Is that better? Because this is, you kind of think of being distributed to this. This is the argument for both of these. And that would go there.
You have to write it that way?
How would you, is there another way you'd like to write it that you think would work?
You have to, oh, all right, I see what's going on.
You see that we did cosecant of this, cotan of this, and then sine x, and the negatives canceled out. Is there, I mean, I'm up for...
Since,
Well, I mean,
Since
can you not cancel just the sign, like leave it as it is, because you can put
this cosecant is 1 over x times sine.
Right, or it's showing it's distributing the whole thing.
I think that's the way they're going to want it. You can try what you're saying. You've got 3 chances for it. Throws you out.
But what I'm saying is, if it was just written as top without taking negative signs out, would it still be the same answer?
Oh, yeah. I mean, that certainly would be it. But simplifying, you should say negative times negative is positive. Is that what you're saying? Just take it. You could leave the negatives in.
No, like I
Oh.
would, like I did that, and then I'd rewrite it. So you can't win it out.
Yeah, and it might let you do that. This is just kind of going a little further, maybe. I don't know. Feel free to try that. Again, you do have 3 tries on a problem before it's going to say no. But I think that's what it's kind of expecting. Okay? All right. Number 5. We've got y equals e to the negative 13x. Got here. So dy dx is what? E to the negative 13x times negative 13. There we go. And so typically we would put that number in the front. So we would have negative 13 e to the negative 13x. Is that good? All right, on number 6, what would be the first thing you would do to attack that problem? Rewrite it. Good. And so how would we rewrite it?
Negative 2 plus 3 to the 1/2.
To the 1/2. Okay, that's going to make it easier for us to use the chain rule and do what we need to do. So then when we take dy dx, we're going to have 1/2 times this to the what power? Okay, negative 1/2 times what? 3. Okay, now, when there's a radical in the answer, typically they want, in the problem, typically they want you to put it back into that form in the answer. So, probably 3/2 square root of negative 2 plus 3x. Because this is 3 times 1/2, so that's your 3/2. And then this would go to the bottom and back into the radical. Okay? Good on that one? Okay, whenever you do the power rule, remember you bring that to the front and you take a whole 1 away from the power. So 1/2 minus 1. All right. Now, what do we got here? Product rule. And it looks like it could be a little mess. See? So we got some chain rule going on. We got all kinds of things. What I would really suggest is to do your road map. Okay? So we would have 3x plus 4 to the 4th times the derivative of this piece plus this piece times the derivative of that piece. Okay, so we're really only taking the derivative here and here. Okay? So we got 3x plus 4 to the 4th times what? Or I'll put this like this. What happened? What did I do? What did it just cover that up? Go back. I need it not covering. What's up? I don't know, but that's very weird. Okay. All right, well, can we just make that? What was this? To the 4th. And that's to the negative 3. And that's to the negative 3. And that's... Okay, so we're good. Okay, so what's the derivative of this guy? Negative 3 times this times what? 4. Positive 4. Plus 4x plus 1 to the negative 3 times, what's the derivative of this one? You know, I just need to, stop that. What happened? Did I... Oh. It's a sign.
No pun intended.
Yeah, thank you. Times what? 3? It's a sign. Did I do something wrong because I got messed up with my thing? What?
4x plus 1, wouldn't it be negative 4? Over 1. The negative 4 left to
Over here.
the first derivative. Wouldn't it be next to the negative 4?
Yes. But, I could have said that I wrote it there and it just disappeared. And that would have been a good reason. But, yeah, you're absolutely right. Okay, did I get this one? Yeah. Okay. So let's start cleaning that up a little bit. Did I mess something else up?
No.
Good.
I'm not pleased.
Okay.
This is probably an easy question. Why do you know to do the chain rule?
Anytime you've got a power like that, and you've got something in here other than just a plain old x,
Okay.
if you've got 4x in here, if you've got x squared, anything in here besides x, you're going to have to multiply by the derivative of what's inside. Okay? All right. So, we have this guy. What can I do with this? Negative 12 times that. Okay. And then I've got this. And 12. I feel confident that you will catch me if I make a mistake. Okay. So, this is where the algebra comes in. All right, you've got all that. Nobody wants you to multiply a bunch of stuff out. What we do want to do is think about, could we factor some things out? Could we clean this up a little bit? All right, what are the common factors, common things in here's a piece and here's a piece? Do we have a 3x plus 4 to a power? And we have it here as well. Do we have a 4x plus 1 to a power? And we got it here. And there's a plus in between. So we're really looking at this piece and this piece. And we got to factor out some stuff. Okay? So we're going to factor out those two things that we talked about. We're going to factor out. All right, when you factor, you want to take the one with the smallest power because you can't take the biggest power out of the one that's not as big, right? Like you can't take x cubed out of x squared. So if you have an x cubed and an x squared, what do you factor out? The x squared. So out of this 3x plus 4 to the fourth and this one, which one are we taking out? To the third. Okay, so I'm going to factor out that. 3x plus 4 to the third times 4x plus 1. Now, look at those two. Which one's coming out? The negative 4 is a smaller number. Okay? When you're talking negatives, remember that negative 4 is smaller than negative 3. So we're going to take that out as well. Okay? We're factoring these out, and we're going to see what's left. Okay? Because it's like you had, Dinah, and I'm going to erase this, so don't write this, but if you had 3x squared times 4x cubed plus 2x squared times, or we'll say to the fourth, times 8x to the fifth, or whatever, and these are being added, what could we pull out? We can pull out an x squared. Well, I should have different variables or something. That doesn't really get it. But you're taking out something in both pieces? Is that, because that was just goofy. But x squared would have come out. You were right. Okay. Think about it this way. All right, out of this piece, if I take out one of these to the third, what am I left with? So 3x plus 4. And what's left here? Times negative 12. Okay? Plus, if I take this guy out of this one, what is left? 4x plus 1. Because what?
Because it goes to a positive, it would go to a positive.
Because if you're taking this out, it's like you're dividing. So you have 4x plus 1 to the negative 3 minus a negative 4. Does that make sense? So that's 4 minus 3, which is 1. So it's 4x plus 1.
Sorry, what was it?
Here,
Oh, there.
that's over there, and it was left. Okay, so we got 4x plus 1, and we're taking out this, so what's left here? 12. Okay, everybody got that? Okay, can we clean this up in here? This looks like just plain old x's and numbers. You do that for me. Clean that up because we have this other stuff still out here. I'll write that and you get me that answer.
Couldn't you factor out a 12 also? Since those are
Yeah, negative 12.
You could, but I think it's going to...
4x plus 1 minus 3x plus 4.
Yeah, do this for me and see what you get, and let's go with this, and then we'll see if we would have wanted to do that. What do we What are we getting?
X minus 3.
Would you want us to go another step and factor out the 12 then, or just leave it like that?
Well, actually, their answer left it like that, but I totally get if you did that on a test, Cody, you know, if you pulled the 12 out and had x minus 3 and then a 12 out, that'd be fine. Okay? But the only other thing that I would do is get rid of this negative exponent. So I would have 3x plus 4 to the third times this over 4x plus 1 to the fourth. And then I'd be done.
Times 12 by 3x.
Where? Here? And multiply by what?
12.
These two are multiplied together. Up here? Yes. So if you did that, you had negative 36x and 48x. 12x. Okay. So if you did all those pieces, that's what you'd get.
X minus 36x, so that gives you 12x minus 36. And then she took the negative 4, you see the 4x plus and the negative 4, and you can take that and you can move it to the bottom and make it positive x.
Okay, so you knew how to do the product rule. You pretty much know the chain rule. What sometimes kicks you on that one is the algebra. Just the factoring and getting it cleaned up. Okay? MathLab will not be as forgiving. I mean, they'll have it, they'll want a certain way, you got to get there. Okay? On a test for me, like if you pulled out the 12, that's going to be okay. I mean, I'm going to have to examine tests. I always do in calculus because it takes a lot more to grade those than, say, a regular class. So, keep that in mind. It's the algebra. All right, let's try this one. It's trig, but same idea. We've got r equals sine theta to the 7th cosine 5 theta. Is that a product? Okay. So we would have sine theta to the 7th times the derivative of cosine 5 theta plus cosine 5 theta times the derivative of sine theta to the 7th. So I've written the roadmap. You try to work that one. It's not very long. Let's see what we get.
So since that part is inside the sign, that means it doesn't go to the outside.
Which one?
Just like the sign theta to the side.
Right here.
Inside the function, that means it doesn't go to the
Right, right. It's
So
not,
if we
yeah.
have the sign like that,
Right, because it's not sine, yeah. See if you agree with that. I think that's about all we can do with that one. that what you got, Lucas? You got that, Drew?
You put an extra sign.
Did I? Of course I did. Where? Stop. Stop. -5. Like here?
Okay, that's what I got.
That's what you got. See, you led me to believe that I had not written something that I didn't need to write. Got to count on you. All right, anybody have a question on that one? You good? Lauren?
I'm trying to figure out how you got the derivative of cosine 5 theta. I just got negative sine 5 theta. I'm not sure what the other.
Here's your argument. And remember that you take the derivative of this, write it there, your argument stays the same, and then multiply by the derivative of the argument. So the derivative of 5 theta is 5.
I thought that was something that was a power, so.
Well, with trig, it's whatever's in the argument as well. Okay? Okay? Are we still writing? A little bit? Are you still writing? Or are you good? Lee, you good? Okay. All right. Now this one has a multiple choice, but you're probably going to need to do the work to get there. So let's see what we can do. What do we recognize that this is? It's a power, but so if we had 9, and there's those t's that we hate, secant t to the what? 8 times the derivative of t secant t, which is a product. So I'm going to let you do the product. And then you tell me which choice that would be.
Why is the derivative of 2 secant t?
When you have that power here, subtract 1 and then multiply by the derivative of what's inside. So we have to do that.
Well, the only logical explanation without doing all the work is a.
That's the only logical explanation. And tell me why.
Well, as long as you know, you recognize the power of the 9,
So-
you already know it's either going to be A or B, but then you can figure out that you got to do
Right.
the product.
Good analysis. But it won't be multiple choice on the test. So keep that in mind. Oh, it might be, because it's going to be online. Could be. Although I might make it not. Do what?
Entire class of calculus students committed suicide this weekend.
No. It's horrible with those T's. I know.
Actually, at the point where I'll actually like circle my addition and multiplication signs.
Oh, that's a good idea. I'll just highlight them.
I just switched it to X.
There were many, many tests where everybody changed it to X's. I just got used to that. That's fine. Okay, so that, do we agree that that's the derivative of that? Is that right? And then you're multiplying by that, so Keith's assessment was right. You definitely could know that it wasn't, I mean, it was here or here because of the 9 and the 8, and then it was, you didn't have a derivative of that. So definitely you could figure that out by analysis. Okay. Not a lot of work on that one. Okay. Okay, this one's a second derivative. Second derivative. This one has some factoring and some other stuff. This would be a really, really good one for us to just try. We'll do the first derivative together. And
Let's work it all by ourselves.
oh, go for it. Go for it. There'll be a pause on the video, but I can't pause it, so just do it. That'll be good. That'll be the very first step you'd want to do.
Rewrite.
Rewrite.
Wait, so that wouldn't be. Why? Because you have to put it together and then take the derivative of that.
And it'll be another product. Yeah. So did you get this for the first derivative? Okay.
I thought you wanted it in positive exponents.
I'm not done because it doesn't ask for the first one. So you leave it there because it's easier to work with if it's in that form. I think I changed it when I got to the bottom. And then you start out on the second one. Amber, did you get that? Okay. So you were good.
where you took the first derivative,
Mhm.
the 4 plus 5 over x. If you had just left it as 4 plus 5x to the negative first,
That would have been fun.
it would have been harder.
I don't think it would have been far harder. I was sitting here thinking why I didn't do that. Mm-hmm.
So, like in real life situations,
Never, never.
you have to do it.
In real life, are you going to have to do this?
Yeah.
Is this real life?
Like, are you going to engineers?
Ask the engineers. I'm not an engineer.
I hope not. I hope not either.
I mean, you're going to use
You're gonna use a lot
some
of it.
calculus, but I don't.
You don't use this too much. My brother's, I went through some engineering, and my brother's an electrical engineer. You don't use this much calculus.
Okay. So there you go. They make doctors take Cal 1, and I don't think they're ever going to do that. Yeah. Yeah.
It's just because they want you to think outside the box. That's what
Yeah.
calculus makes.
Well, it's kind of like when I got my master's in math. I took courses that I've never used since. And it was really about the rigor of doing it and the rigor of sitting in front of PhDs asking you questions and all of that. That's what it was about. But I haven't used those courses. Now, maybe if I were teaching, at a 4-year university, I would. But not here. So, yeah. So it is about the process as much as anything and the rigor. But you guys that are engineering majors, do you have to take all the way through Cal 3?
Yeah. And then
Do you have to take differential equations?
Yeah, differential equations.
Statics.
Long math.
Well, differential equations wouldn't be too bad after this.
But you
No.
realize as engineering, that's all you're going to be doing, right? Well, mathematical equations.
Yeah.
Okay.
Yeah.
I do
How
that.
do you know that? My grandfather was an engineer. All I did was sit behind a desk and do math.
Is that what you want to do? Is that why you're doing this?
I once I realized that, like, I'm alright with math, but I mean, like, I don't focus on it enough to where, like, it's enjoyable to me.
Oh, it's not enjoyable to a lot of people.
No, but if I focus on it hard enough, I'm good.
Right.
I just can't stay focused with it.
So what is your major that you're taking?
My major right now is actually art.
And you have to take this?
No, I'm going back over because it's taken 2 times, and I just don't want to deal with what I had as a grade. I'm going to
Okay.
take it so it's actually a good grade that I actually focus on.
Gotcha. Art and math are really a lot sometimes.
They're fairly similar.
Yeah, there's a lot of stuff in there. Okay, how are we on this? Did we factor and get that? You did? Oh, you're just saying, yes, got that. One of the I think this may be the question, I don't know if it was this one. There was one that I worked on in the summer, and I couldn't get what it needed to be, and I was so angry, and it was just a little sign error on my part, so I totally empathize with that. But let's see if that all makes sense.
Can you explain that out?
I thought you said you take out x to the negative 4th because it was small. Can you do that or no?
I don't think that's not right there, is it? Is that what you got?
Yeah, that's right. You did 2 times the negative 5x.
Yep.
And then times that to the 15.
But when you factor down at the bottom, can you take out a 30x to the negative 4th?
I'm hearing you. I'm looking at this, and did you guys do that? Did you take that out?
That's what I did.
So your answer at the end was what?
I really don't know.
Oh, okay. Will somebody else finish
He doesn't want
it?
to answer it because he doesn't want to be wrong.
Like that.
Will somebody else work on that? Because I agree with you. I'm not sure why I
You're
didn't.
saying just take 30x to the
30x to the negative 4 out. But what did somebody else do? Did anybody else finish this? You're trying? Okay. Lucas, you doing it?
Worked on it.
Okay.
Where'd your Your 4 plus 5 over x squared.
It's right here.
Yeah.
But if you pull out 1,
Oh, okay. I see.
because this is what I factored out.
I see what you're doing.
But the question is on the table, should we have factored out x to the negative 4?
Well, I'll try.
I mean, it's not that it's going to be wrong the way it is. It might not be factored as simply. You can take out the x to the negative 3. No, you can't.
It's larger than
Wait, what's wrong with that?
It's okay. I mean, what I got here, here's what happened. I mean, you typically can't take it out because it's bigger, but I ended up with 5x to the negative 1. Right? Do you guys see that? Or is anybody with me?
Well, but like, when you take it out, the only thing that would be the difference would just be x.
And I think because there's a 5 over x here, when you take that out, you end up with a 5 over x here. And so you've got 10 over x because you're adding these guys.
So that's fine.
That's probably why I did it. I have slept since I did this problem, so I'm trying to rethink why I did it, but that probably is it. It wouldn't be wrong if you did it the other way. You'd just probably come out a little bit different at the end. Does that make sense? Why did I take this out? Well, what can you take out? You could take out 30 out of 150. Does that make sense, Maheen? And so I did that. The question we were debating was, should I have taken out 30x to the negative 4? The other reason to take this out, if you take out 30x to the negative 4, you're going to still leave something here. Right?
Wouldn't it, if you took it out, it would just be, I got 9 plus 5 over x plus x, instead of your 5 over x plus 4 plus 5 over x.
Say again what you got.
Well, like, it'll just be 5 plus 4 plus 5 over x plus x.
I don't know. I know this is the answer that they got.
They got
So, since you're going to have this kind of problem, probably go with this approach. Okay? Because what I did was look at the final answer and say, did I get what they had? So when I was trying to work it for you. Okay. Did you try it the other way?
Yeah, I'm actually at that point now.
Still working on it?
So,
Okay.
So that other problem we did,
Yep.
should we have just taken,
No, we should have done it that
we
way.
did it that way?
We were good there. This one was kind of a weird problem.
Okay.
Lauren, question? No? We're good? Okay. Lucas, question?
I'm just trying to understand. When you factor out the 30x to negative 3, what do you do with the other?
And one of these?
5x that's left over on the 150x to the negative 4?
Right here. Here it is.
What she did is she took out the 30x minus 3 and a 4 plus 5x.
Right. So this is what got factored.
Yeah, I was confused too. I was looking at like, wait.
Sorry.
That's
It
what I was
probably
looking for, those brackets.
better there. Okay. And so that's left out of the 150x to the negative 4, and then this is left out of this part. Right?
Yeah.
Okay. Simple brackets could have made it better to start with. Okay. Leland keeps looking from this side to this side. I think they're the same. It's not going to be any better over here than it is over there. Sorry.
It's math.
It is math. All right. Symmetrical. Yeah. Are we good? Delana? No. No, no.
So out of the 3 calculuses, which one's the hardest?
When I took it, it was 2.
2.
For me, yeah. 2 was the hardest. I made an A in the first one and an A in the third one and a B in the second one. It was way back when.
It's gotten harder, hasn't it?
I don't know. Is that it for those? Yeah. Okay. So, hold on.